Hey class. So today's lesson in math is all about constructing figures. So we're on to lesson 4 of our geometry unit. And the learning objective for today is construct polygons using a variety of tools given angle and side measurements. Some of the tools that you guys will be using today are the protractor and the compass. We're not going to be using these tanagrams today, but they're also really useful when you're constructing figures. So something important I wanted to go through with you. So in your homework the last few days, you might have noticed when you were working with different triangles and angles that there's a certain pattern. So when it comes to triangles, all of the internal angles, that's the angles on the inside, add up to 180 degrees. So we have angle A, angle B, and angle C, and they all equal 180 degrees. This is really evident in an equilateral triangle, and that's where all the sides and all the angles are the same. So in this case, because 180 degrees divided by 3 is 60, all of the angles of an equilateral triangle would be 60 degrees. Okay, and these lines here just mark that it's the same side, the same length of side. So each angle in an equilateral triangle is 60 degrees. Why this is really important is that when we're doing questions in math in the future and for this lesson, it's a great way to figure out missing angles. So if you're given a shape and you're told that one of the angles is 80 degrees, one is 30, then you should be able to figure out the third angle by just adding up these two, 80 and 30, and subtracting it from 180. So here we have 30 plus 80 plus x, which is a missing angle, equals 180. So we add 30 plus 80, which is 110, plus x equals 180. And then we know if we do 180 minus 110, that gives us 70 degrees. And then that's the leftover angle. Okay. To break it down even further, if you want to see why this is let's say we have triangle ABC here. If you were to construct a parallel line, so this is line D and E that runs parallel up the base of this triangle. Anytime you have two parallel lines and you intersect it with another line, the angles that are formed by the alternate sides of that line are equal. So they're called alternate interior angles. So this one right here. Okay, so in this case, we have the internal angle of A in this triangle. It would be equal to this angle right here, which is A. And it's the same case with this line. So this line BC is intersecting these two parallel lines, and the angles that are formed are also equal. They're alternate interior angles. So with that information, we know that a straight line, a straight angle is 180 degrees, okay? And we know that this straight angle is made up of A, angle B, and angle C. So if you were to add those all together, it would be 180, okay? In the same way, we know that A is the same as this interior angle to this triangle, and C is the same as this one. So that's a way to break down why the interior angles of a triangle equal to 180 degrees. There's another rule, and that is with quadrilaterals. So there was a question in your last homework that asked, what do you notice about all the angle measurements of a quadrilateral? So with the quadrilateral, all of the angles would equal to 360 degrees. Okay, and this relates with the triangle rule, because if you were to draw a line dividing this quadrilateral, it would divide it into two triangles. And we just learned that the interior angles of triangles equal to 180. So if that's the case, if it's made up of two triangles, then we know that the interior angle of a quadrilateral would be twice 180, which is 360. So in that case, angle A, angle B, angle C, and angle D equal to 360. You can see this when it comes to a square. We know that a square is a regular quadrilateral because all the sides and all the angles are equal. And the angles in a quadrilateral add up to 360. And we know that a square has 4 right angles. Okay, so 90 plus 90 plus 90 plus 90 equals to 360. Again, this is useful when we need to work out a missing angle. So in this case, we have the angle for 3 corners of a quadrilateral, but we're missing the last one. So if we know that we add these 3 and we subtract them from 360, it gives us the missing angle. In this case, it's 85 degrees. So this is very helpful when you're given questions that have some information but are missing other bits of information. So for today, as I said, the learning objective is to construct polygons using a variety of tools given angle and side measurements. So this question right here says, construct triangle. Whenever you see this little symbol, it means triangle. So construct triangle ABC with sides AB being 6 centimeters, AC being 5 centimeters, and BC being 4 centimeters. Now, you could try and just draw any triangle and just put in the measurements, but it wouldn't be correct, okay? So there is a way to do it where you have to use a compass in order to do this. So the first thing you're going to do, it says here, step 1 is use the ruler to draw a segment AB, which is 6 centimeters long, because AB says here 6 centimeters long. So that's the base of your triangle, AB, and that's 6 centimeters. All right, so we just need to figure out now AC and BC. So I'm going to go to the MathPad. All right, so now I'm in MathPad, and we should be fairly familiar with MathPad, as this was one of your homework assignments. So I've just started by pulling up my ruler. I'm going to pull it down, okay? And I want to start with constructing the first side of my triangle, okay? So your question asks you to construct this triangle, and the first side is AB, and AB is 6 centimeters. So I'm just going to draw that base of 6 centimeters. Okay, so I start at the 0 and I pull all the way to 6. Okay, there we are. I'll get the ruler out of the way. This tool, unfortunately, doesn't have any option for text, so I'm just going to have to draw it in as best as I can with freehand. So we have A, B, and that was 6 centimeters. So I'm just gonna put this so it's easier for you to visualize by putting the measurements. Okay, there we go. All right. So now to construct the other sides of my triangle, I'm going to use the compass. Okay. Oopsies. Okay, so I'm just going to pull it out of the way for now. All right. So with the compass, I'm going to start by trying to figure out the side that is 5 centimeters. So it says AC is 5 centimeters. So what I'm going to do with my compass is I'm going to pull up my ruler, all right, and I'm going to just drag my compass. Make sure that you have the hand showing, and you're going to drag one point of the compass to the 0. Okay, I don't know why it's snapping there. Maybe I'm going to pull it out of the way a bit. Okay, so you're going to pull it to the 0 right there. Perfect. Okay, and then you're going to just pull this side of the compass with the pencil until you reach 5. Okay, and then you can just lock it in place. Then you're going to drag this side and just put it on the side, the A. Okay, remember we're drawing the arc of AC. Then I'm going to pull my compass up. Oops. And I'm going to just draw an arc. So the way you draw with the compass is by pressing the black part, and voila, you're just going to draw an arc. Basically, this arc means any distance from A to the arc is 5 centimeters. So from here to here is 5 centimeters, from here to here is 5 centimeters. If I were to do a circle all the way around, which I can, it would mean that the distance from the A to the circle is 5 centimeters. All right. Next, I'm going to draw the arc for B. So BC, the side length is 4 centimeters. So I'm going to just bring my compass. I just want to flip it around. Okay. Whoops. Sometimes it's a bit finicky. So I'm going to bring it, I'm going to line up the point at the 0. I'm going to unlock it. And then it says 4 centimeters for BC. So I'm just going to line up my pencil to the 4 as best as I can. Okay. Then I lock it in place. All right. And then I want to line up this point with B. I want to flip it around. There we go. Okay. And I'm just going to draw the arc now for B. So I press the black part of my compass and I just go like that. So that's actually where the line would intersect, the two lines. So this point that I've made here, I'm going to just put a dot, okay, and I'm going to label it C. And then all I'm going to do now is I'm going to draw segments AC and BC to complete my triangle. So I start here, I draw the line segment all the way to C, and then one here, and I draw the line segment all the way to C. Okay, never mind these curved lines, that's fine. When you are doing it on paper, you would have a pencil and you could easily erase that. And the curves you draw wouldn't be as big as the one I did. I just did it to show you an example. Okay, and then I'm gonna fill in the other measurements. So on the question, it says AC is 5 centimeters. And BC is 4 centimeters. There you have it, okay? So I've drawn a triangle, A, B, C, with the measurements that they gave me, okay? And that's how you use the compass. So what do you notice about this triangle when you look at it from what you've learned about triangles? Well, you can see that it does have an acute angle. It's actually an acute triangle because all the angles are less than 90 degrees. Okay. All right, perfect. I'm going to show you now another question. Okay, so we're back to our slide, and you can see that the triangle that we made was pretty accurate. So you can see that the arcs are very light. Okay. In MathPad, they're a bit darker, but remember you want them to be just very faint because the focus is really on trying to figure out the triangle. Another important thing to note is when an angle is identified by 3 letters, the middle letter indicates the vertex of the angle. So for example, angle A, this is angle A, is also called angle CAB, and A is in the middle. Okay? Now we're going to go on and we're going to construct a parallelogram. So this will be parallelogram BACD with the following side measurements and angles. So AC equals to BD and it's 5 centimeters. As you know, with a parallelogram, there are 2 pairs of parallel sides. So AC and BD are both 5 centimeters and BA and DC are 2 centimeters. This is not how it will look, but this is just an example of how a parallelogram looks to give you an idea. And it also gives you 2 angles. So it shows you that angle ABD, which would be something like that, would be 120 degrees, and angle BDC, which is something like this, would be 60 degrees. Okay, so you see this is not correct, but this is just to show you how a parallelogram looks. The first thing you want to do is, just like with the triangle, you want to use a ruler to draw segment BD, which is 5 centimeters long. Okay, so with the side measurements and the angles, we're going to be able to build this parallelogram. So let's go over to MathPad. Okay, so it's time to start constructing my parallelogram in MathPad. The first step is that I want to use a ruler to draw the base of my parallelogram. which is segment BD. Okay, so segment BD, the measurements are 5 centimeters. It's a good idea to try and create your shape more in the middle of the application so that you're not running out of room on the sides. So I start at 0, I go all the way to 5. Okay, I'm going to get rid of the ruler, and now I'm just going to label this line. So B, D. And I know it's 5 centimeters. Okay. All right, so some other information I'm given is that the sides of my parallelogram are 2 centimeters, okay, and we know that the upper line is 5 centimeters because it's a parallelogram. But I need to know the angle at which the sides lift from this line. So for that, I am given the angle measurements. So I'm given the angle measurements ABD to be 120 degrees and BDC to be 60 degrees. Okay, so let's start with ABD. All right, I'm going to use my protractor. I want to make it a bit smaller. I'm just going to align up the middle to the vertex, okay, the edge of line B. And then I'm just going to now measure 120 degrees. So starting at the 0, I'm going to go all the way up, okay, and here we are at 120 degrees. I'm just going to make a dot, and there's a reason for that, rather than making a line at this moment. So let's move the protractor out of the way. All right, I'm going to use my ruler. So the reason I've made the dot is because I need to measure out 2 centimeters. Okay, so basically I want to line up my ruler with that dot. So I'm going to put the 7 here. And I'm just going to line it up right there. And you just got to play around with it until it is nicely aligned with the dot. Okay, just a bit more. All right, not too bad. So I am going to now, maybe I'll move it a little bit more over. Okay, I'm going to make this line segment of 2 centimeters. So starting at the 7, or the base here, I'm going to pull all the way up. So 1, 2, just 2 centimeters. Okay, so it's starting to look a little bit like a parallelogram. You should be able to see it coming together. So I'm going to label this side as, I'm labeling it as A. Sorry about that. Okay, and it is 2 centimeters. Excuse my freehand drawing there. Okay, and then I'm going to now figure out the angle for BDC. So again, I put the center of the protractor against line D. I'm going to get my pencil tool, and I want to measure from this side now because I know the angle is lifting this way. So I'm going to go 0 all the way to 60, which is over here. Okay, I can get rid of my protractor, use my ruler tool. So I'm just going to now close off this shape. It's pretty close. Okay, that looks good to me. So starting here, let's move it a little bit more in. Starting here at the base, I have my pencil lined up, and I'm just going to go all the way up to 1 centimeter, 2 centimeters. Okay, it's not perfect, but you know, it's close enough. And then now I'm going to connect these 2 lines. There we go. All right, I know that this is C. It is 2 centimeters. And then this one, who can guess how much the measurement of AC is? You're right, 5 centimeters. Okay, there we have it. So that is how you create a parallelogram using a compass. Okay, so you can see that the parallelogram we created was pretty accurate. Okay, there's all the measurements. And then you can always check to make sure that your measurements were correct by measuring the side of AC to see if it's 5 centimeters. Okay, so that's generally what you'll be doing in your homework assignment. You're going to be given side lengths, you're going to be given angles of shapes, and you have to create it using the compass and the protractor. I'm just going to do one more with you. And so the question is, construct triangle XYZ when you have the length XY as 6 centimeters, XYZ as 40 degrees, and YXZ as 50 degrees. Okay? Can you determine the lengths of the other sides? And what is the size of the angle Z? All right, so we're going to go over to MathPad again. All right, so the first thing I want to do, I'm given the measurement, the only side I'm given is 6 centimeters, which is XY. So I'm just going to get my ruler out, and I'm going to create my base of XY. Okay, I'm going to do it a little bit more in the center so I don't run out of space. Okay, so I know it's 6 centimeters long. Okay, so I can put my ruler away, and I'm just going to label it XY. So we have X and Y. And I know that it is 6 centimeters long. Perfect. All right. The other information I have is that the angle of X, Y, Z is 40 degrees and Y, X, Z is 50. So I want you to think about what I'm going to do on my MathPad. Okay. So some of you might be thinking that you should be doing something with your protractor. All right, if you're thinking that, you are correct. So I'm going to get my protractor out. Okay, let's make it a bit smaller. Oh, good, it is small. Okay, let's start with angle YXZ. Okay, so that is this one here, YXZ. Okay, and it said that YXZ is 50 degrees. We can even just say angle X. Angle X is 50 degrees. So can we make an angle that is 50 degrees? Yes, we can. So I line up my protractor in the middle to the corner of X, and then I am going to just, this time, I'm actually just going to create the line, okay? So I'm going to start here, and I'm going to go all the way, so 10, 20, 30, 40, 50, 60. And right now, I don't know how long this length of my side is. So if I had a pencil, I could just erase the excess lines. In MathPad, I can't really do that, but I'm going to do it anyways. I'm just going to make it a bit longer and until it intersects with the other one. Okay, so right there, I know the line's probably way too long. Okay, and then I'm going to look at angle Y, and angle Y is 40 degrees. So XYZ is saying it's 40 degrees. So let's line up my protractor at angle corner of Y. And I'm going to get my line. Okay, I'm just going to start here. And remember, we're going up from 10, 20, 30, 40. Okay, I'm going to pull that all the way out. All right, and you can see that the lines intersect right there. Okay, so in fact, I'm just going to put I'm going to put a dot so we know the corners of our triangle. If you had an eraser, if you're doing this on paper, you would obviously erase these lines, but on MathPad, we don't have those luxuries. So I'm just going to put here Z, because that is the name of that angle. All right, so we're not stopping here because the question asks us, can you determine the lengths of the other sides? So how are we going to do that? Okay, if you're saying use the ruler tool, you are correct. So I'm just going to flip my ruler around. Okay. And let's measure line XZ first. So we'll just put it at the 10. And my guess is that these angles, these line measurements are going to be, whole numbers, not decimals. So even though right now it looks like it's a decimal number, it's not. So here we have 1, 2, 3, 4. Okay, so I'm going to write down 4 centimeters. And then let's look at this side. So we're going to turn, actually, yeah, we'll turn our ruler around. Okay. Let's line up our ruler against this line properly. Okay. And as I said, whoopsies, it's going to be a whole number. So 1, 2, 3, 4, 5. All right, so let's put in our measurements. Perfect. Okay, so we have the sides. We know our angles. We can even write our angles. So angle X was 50 degrees. Angle Y was 40 degrees. Okay, you'll remember in the beginning of my lesson, I had mentioned a special rule when it comes to triangles. I want you to see if you can use that rule to figure out the angle of Z. So I know 2 angles of this triangle. I'm missing 1. So 1 missing 1. How do I figure it out? Okay, some of you might be saying, you know that X plus Y plus Z should equal to 180 degrees. So if I add up X and Y, so what is 50 plus 40? Okay, I'm hearing some of you say 90. Okay, so I know 90 plus Z equals to 180. Who can figure out what angle Z is then? What number do you add to 90 to get 180? I'm hearing some of you say 90 degrees. So isn't that funny? So this angle is in fact, what do you call a 90-degree angle? Okay, so it is a right angle and it is 90 degrees. So we actually just made a 90-degree triangle. All right, there you go. Okay, so basically this is this assignment, you're just working with the information that you're given to construct the different figures.